Hi there, my name is Brian Dill, and I'm here to present to you the first section on the Programming Level 3 course, as well as what our textbook has to offer. The second part will be presented by my colleague and co-author, Shani Nunkumar. The aim of the Programming Level 3 course is very similar to that of Programming Level 2. It's an opportunity for students to engage with software development and writing programs, and that they will do using real-life contexts and solving problems within those real-life contexts. Students as a whole benefit from developing their problem-solving skills, not only in this particular course, but throughout their other courses that they may be studying and throughout their life as well. They also learn how to take really big problems that may seem overwhelming at first and then breaking them down into smaller sections and sub-problems, and also to reuse previous solutions that they may have come across and that are still applicable. In terms of the teaching time, the offering is intended to spread over 2 semesters spanning 24 weeks, not including the assessment. This works out to, if one looks at the first bullet point, your 24 weeks, which consists of a recommended 2 double periods, equivalent to about 1 hour, 50 minutes. And in that same week, a single period of around about 50 minutes. This gives you plus minus 45 hours a week over a period, a total of 56 hours. And then of which 36 hours should be direct contact time led by the instructor, which includes the practical sessions, as well as the 18 hours where the students are working on their own in their practical tutorials, but of course the instructor will still be present to lead that process. The students should also spend an additional 10 hours per term, roughly about an hour and a half per week, to practice and reinforce their skills. In terms of resources, the management and the budget, physical resources does require a networked computer lab that in turn has internet connectivity, so that the students can use that as a resource to help them look for material and to solve their problems. This course can be done almost entirely on Windows-based PCs, although of course there are certain sections that specifically do require a Raspberry Pi. And also there is a section on single board computing where the students would need to have access to an Arduino device. The issue around the Raspberry Pis, this course could be completed in its entirety using Raspberry Pi machines or devices, but it is equally possible, if that is not available, for the majority of the work to be done on the Windows PCs. In terms of human resources, you would require a lecturer with a background in programming and a qualification in programming that has the necessary experience to impart this knowledge to the students. The software resources for this course are all available for download free of charge and for use free of charge, so there are no additional costs involved in the software. Teaching and learning materials, you would obviously need some course materials, such as the student book that we have developed, so that there's material for the students to work through, to be guided by, and activities for them to do. Additional to this, when you are busy teaching new material that is of a physical nature, such as the first topic that is about hardware, for example, that you actually have a collection of physical items that the students can handle and inspect. And this helps to make it easier for them to remember if it's something unfamiliar that they've never come across. Then in terms of the infrastructure and the budget, the two sort of go together. A computer lab that has computers that are all in working order, where the students have access to a computer of their own. This is not only essential for the examination and testing side of the course, but also for their daily working. It is really essential that they do have access to their own devices. Budget-wise, the college should bear in mind that you would have to refurbish or replace the computers in the computer labs every 3 to 4 years. It is important that the students are working in a reliable environment, that you aren't going to be suffering unnecessary breakdowns and have students not having access to a computer during their lectures and during their practical sessions. And of course, during any assessment, is essential that it's not interrupted by hardware failure. And that is a very important aspect to bear in mind. In terms of the assessments, as with level 2, there's a practical paper and a theory paper, and all of the 12 topics presented in the course are part of each of these papers, but in different weightings, as can be seen on this slide. Even topic 1, that is essentially about hardware and software, it naturally appears in the theory paper, but note that there's also about 2% of the practical paper that should be dedicated to this topic. That might seem a little strange, but remember that there is a little section in this topic where you do command line activities, much as was done in level 2 with Windows, except that this time it is on the Raspberry Pi in the Linux environment, and that can then be practically assessed. The weightings themselves, obviously, topics 5 to 12, that is the sections on the solution development with the high-level programming language, where the practical paper, 50% of the practical paper should be dedicated to that practical programming. But note too that 40% of the theory paper also relates to the high-level programming language. And of course, this will examine the theoretical knowledge that the student has acquired that leads them to be able to do the practical programming. We go on to the actual topics themselves with just a brief outline of each one. Topic 1 is all about computer hardware and software, which is very similar to what was covered in the level 2 programming course, except it is now looking at different and slightly more advanced aspects. So the first part, the first unit, is all about different types of hardware in a standard computer system, and it then looks more in depth at very specific devices than was done in the level 2 course. In the second unit, there is an emphasis on software and the different kinds and categories of software. And then the last unit, as I have referred to before, is all about using the Linux shell and executing command line prompts and commands. Similar to what was done in the Windows environment in programming level 2 course. And this unit can, of course, be linked back to the student's prior experience in the previous year. The second topic is problem solving in computer programming, which is a reinforcement of what was done in the programming level 2 course. So unit 2.1 is about the problem-solving process, which is just largely actually just a reinforcement of what was done in the level 2 course, and deals again with the steps of the problem-solving process and aspects such as the program development life cycle. And then Unit 2.2 is the practical application, again, as was done in the level 2 programming course, with aspects such as flowcharts and that kind of problem solving on paper that was done in level 2, and that is now just repeated here to assist the students to solve their problems on paper first before they attempt to do it on computer, which is a great time saving and leads to less issues within actual programs. Then the programming for single board computers in topic 3. In level 3, the device that is focused on here is an Arduino, and in our book we've used an Arduino Uno. It also links across to the robotics course, where the similar device is used. And there's a theoretical introduction here, but there is also a practical session and some practical tasks at the end of this topic that requires the students to have access to the actual Arduino devices and to program them. The Unit 3.2, which is about visual programming, block-based programming, using a language such as MBlock that can interact with the Arduino, and which is derived from Scratch, and so very similar sort of environment to what the students should be used to from their level 2 course, using very familiar blocks, and should therefore be relatively easy for the students to adapt to. Then topic 4, programming tools and utilities. This links back to programming level 2, where there was a similar topic that dealt with version control systems, source control systems, which was quite theoretical in the level 2 course. And here in our level 3 course, it is now getting to an actual hands-on use of a version control system. So Unit 4.1 really just revises the concepts around source control and version control. Then it introduces C++ and building C++ applications, how to install the environment on the Raspberry Pi device, how to install the environment on a desktop computer. Unit 4.5 is about debugging your programs. You might find that the students find this a little tricky at this stage if they have not yet written many programs in C or C++, but remember that the programming skills that they are using to program in this new programming language is very similar to what they did in the level 2 course with Python. And you might find that you have to refer back to this Unit 4.5 throughout the rest of the course when the student runs into issues. Unit 4.6 is the actual practical implementation of a version control system using Git. And then there are practical activities where the students can then learn how to use the Git version control system, and also how to apply this practically in their own courses, so that they are keeping their programs safe and are also able to manage the different versions of the different programs. Topic 5 is the introduction to C and C++ as a high-level programming language. Again, as I have just mentioned before, they are applying the knowledge that they have from programming in Python and just transferring it into a new programming language. And obviously, the big challenge is to learn the syntax of the new programming language. It starts off with a simple Hello World application, as is often the case in computer programming courses, and as they also did with Python in the Level 2 course. And then Unit 5.2 breaks down the different parts of a C++ application so that the students can understand what each section of code means and what it's there, what its purpose is, and why it needs to be there. Topic 6 goes further into C or C++ as a programming language and discusses the different data types as they are used in this language. It discusses those data types and what their limits are, the kind of data that can be stored in variables of each data type, the use of the different arithmetic operations, as is common in all programming languages, how you are able in C, C++ to declare more than one variable at a time, the role that escape characters play and escape sequences, and how to use that to create new lines. And then also there's a unit at the end of topic 6 that then takes the students through how to format their output, for instance, to round output to 1 or 2 decimal places, or to display it in columns, and so on. I'm now going to hand over to Shani for the second part of this presentation. Thank you very much.
Hello everyone, I am Shani Nunkumar and I will be taking you through modules 7 to 12 of Programming Level 3. Before I start, I would like to draw your attention to the following points. Point 1, C and C++ is used as a programming language. Point 2, the programming concepts, the core fundamentals that were done in Programming Level 2 still has status in Programming Level 3. These concepts are reinforced and revised in Programming Level 3. Point 3 is that the content is assessed in an integrated manner, both formally and informally. I now take you through Module 7, which is Maths, Interactive Inputs, Constants, and Errors. Unit 7.1, C and C++ keyboard input. We look at both numeric and character input using the scanf function and the cin object. In Unit 7.2, we look at C and C++ errors, and here we look at the logical errors, syntax errors, compile time errors, and typographical errors. A hint to you is that to use code to show learners the different types of errors. 7.3, we deal with the mathematical library. Now, we need, in order to use a library, the header for that library must be declared. The functions that will be tested here is absolute, power, square root, sine, cos, and tan. Now, a hint, we start with the mathematical knowledge of these functions and then equate it to the programming knowledge. The focus here is on learners creating complex mathematical functions using the simple functions that they have learned. Now, the biggest challenge here is that for the sine, cos, and tan, the degrees angle has to be converted to a radian angle using a formula and then applied to the bigger complex function. Unit 7.4, we look at data validation and why is data validation important. And here we have 2 types of validation using numeric range validation and 2 using character character validation, where a character is read and it is compared to 3 other values to see whether there's a match. Not more than 3 though. We move on to unit 7.5, which is symbolic constants. Now here we look at magic number, where a constant is used in a program throughout without actually explaining what this constant means. Now let's look at a deck of cards. A deck of cards has 52 cards, and the learner may decide to create a program using 52 constantly when referring to the total number of cards. However, what happens when a new card is introduced and you have 53 cards? This means that the learner has to go back and modify all the values of 52 to 53. When doing so, errors may creep in. That means certain values may change, certain values may remain unchanged, or incorrect value may be changed. So the solution to this is the introduction of a symbolic variable, where a variable is declared as a constant in a program. Then we will now move on to the next module, which is module 8. Module 8, Selection Control Structures. Unit 8.1, Relational Expressions. Here we look at the use of relational operators in creating simple and complex relational expressions. The challenge here is that we've always told learners that the outcome of a Boolean expression is true and false, and hence can only be assigned to a Boolean variable. However, this is not the case in C++. The output to a relational expression is 0 for false or 1 for true. Hence, the value can be assigned to a integer variable, or it can be assigned to a Boolean variable. The focus is also on the comparing characters. Now, when 2 characters are compared in C++, their ASCII code is compared. So that if you compare capital letter A to small letter a to check whether one is less than the other, capital letter A, the ASCII character code for it is 65, whereas the ASCII character code for a small letter a is 97. Hence, small letter a will always be greater than capital letter A. Unit 8.2, we look at selection statements 1, and here we introduce the if, then, again, and how it affects the flow of a program. We move on to introduce the if, then, else, and again, only to 2 levels. The emphasis here is in creating complex content. Now, what do we mean by complex content? If this Boolean expression is true, then in the then part, there must not only be a single statement, but there must be multiple statements. And this is what is meant by complex content. The concept, we look at the concept of a block. And here we emphasize that a variable can only be accessed in the block in which it is declared. And this is very important for module 10, which is modularization and functions. Unit 8.3 deals with logical operators. And here we look at the and, or, and the not operators, and the use of the logical operators in creating complex Boolean expressions. Unit 8.4, we look at the selection statements 2, and here we focus on the concept of nested if and how it affects the flow of a program. We look at where the condition is a complex Boolean expression using both logical and relational operators. And again, once again, the content must be complex. Module 9, Repetition Control Structures. Unit 9.1, the while repetition control. Now, before we focus on the while repetition control, we look at the different types of loops, which is the pre-test loop or the entrance control loop, the fixed count loops, the conditional control loops, and we look at how they differ. Then we look at the while repeat control loop as a pre-test loop. We look at the use of the relational operators in conditions, and we look at block scope of a variable and the break and the continuous statements. In 9.2, we look at logical operators in the while loop and the use of the and or not for complex Boolean expressions, and once again, compound content in the loop. Unit 9.3, we look at the do while loop, which is a post-test loop. We look at how to exit this loop and how the flow of the loop takes place. We look at the use of relational and logical operators for complex relational expressions in the condition. And then finally, we look at the sentinel control loop. In Unit 9.4, we look at the for loop, which is an unconditional loop, which is executed a fixed number of times. And we look at how this loop differs from the while loop. We look at what is the outcome when a semicolon is placed at the end of the for loop declaration. And we look at the use of the break statement to exit an infinite loop. And we also look at how incrementing or decrementing the loop with a value other than 1. In 9.5, we look at the nested loop. Now, here we look at the concept of nested, inner loop, and outer loop. And very important is how does the flow of the program is affected by the use of nested loops. Now, the looping structures can be of the same type, example, 2 fors, 2 whiles, or 2 do whiles, or 2 different loops. And again, we focus on the flow of the program. In 9.6, we look at program flow and control, and here we look at the use of the continuous statement, and then we look at incorporating all the aspects that have been learned up till now, including the looping structures and how it can be used to solve problems. Module 10, Modularization and Functions, Unit 10.1, Variable Scope. And here we look at the scope of a variable. A variable can only be accessed in the block in which it is declared. We look at local and global variables and how to change a global variable. Unit 10.2, we look at the functions, and which is built-in functions versus user-defined functions. Built-in functions are the library functions, and the user-defined function is where the user actually defines a function. We look at the concept of modularization and how a larger problem is broken up into smaller pieces and solved. We look at the difference between called function and calling a function. We look at how to declare a function, the function prototype, the function declaration, the function header. The function must always be declared before it can be referenced. We look at the difference between a value returning function and a void function and how these are called. In Unit 10.3, we look at random number. Now, a random number is a number that is generated by chance. When you're generating random numbers in a computer, we first have to declare the file header to generate a random number. And a computer-generated number is referred to as a random pseudo-number because it is not truly random. The rand function generates a random number. The rand max is an integer constant that returns the maximum value that can be returned by the random function. This maximum value may differ from computer to computer, I suppose, depending upon the computer architecture. The srand function sets the seed for a random number. Now, if a constant seed is used, then each time that the program is run, it will generate the same random number. In order to avoid this, to get different random number, use the computer time as a seed if you want different random numbers, because the computer time is measured in seconds, and the seconds keep changing all the time. And that brings us to the end of module 10. Module 11, one-dimensional arrays. Unit 1.1, one-dimensional arrays. And here we focus on array elements, subscript, and declaration. Array as a data type. We look at the atomic versus scalar variable. Atomic only allows one thread to run at a time. A suggestion is that use a database, preferably an online booking system, to explain the use of scalar and atomic variable. We're looking at declaring an array with the constant elements, outputting, modifying, and assigning values to an array, initializing an array, and inputting values into an array. And this will bring us then to the end of module 11. Module 12, Concepts of Object Orientation. Unit 12.1, the fundamentals of object-oriented programming, which is OOPS. This is completely new to the learner, and therefore lecturers should spend time on this section. My suggestion is that you use an example such as a car prototype, the class, the instance of the class, the car, which is an object, and the actions that can be performed on the objects, the methods. The abstract, we look at the abstract data type of classes and methods, the instantiation of an object, built-in function classes in C and C++, external classes, how to call calling methods of the object class from an external class. We move on to unit 12.2, which is the string class. Here we look at how string literals are always found within double quotes, whereas character objects within single quotes. We look at a string as an array, the concept of a string object, the concepts of outputting, modifying, and assigning elements, individual elements of a string, inputting and outputting string variables, the use of the getLine function. The C in object is stored with a delimiter, which is /n. So when you read from the input buffer, it will read firstly everything before this delimiter /n. And when you read the second time, it'll read the new the /n as data as well. So that raises the problem of the phantom new line. In order to get rid of the phantom new line problem, we need to use the getLine function twice. The second getLine would be a dummy read. So it will be getLine open cin, comma, string. We move on to 12.3, which is string processing. And here we look at the different string methods, which is the length, the index at, the compare, the erase, the find, and the substring functions, and the use of these functions in problem solving. Unit 12.4 is using the cout and the cin objects. And here we look at the header for which must then say hash includes IO stream. And then we look at the stream insertion and the extraction operators. The C out is for output and the C in is for input. And this brings us to the end of module 12. We will now be ready to look at assessment. Assessment, we look at internal assessment and its weighting. When we look at it, we have components. Internal assessment forms 50% of the total marks, whereas external assessment forms 50%. Now, the task, if you look at it on your right-hand side, we have ICAS, which is actually internal continuous assessment. The weighting per task is 50%. Then we look at external now, which is your integrated summative assessment task, which is ISET, which is 15%, and it is compulsory for learners to complete. Then we have an external examination, which is a summative assessment task, which forms 35%. So as you can see, the two external components, exams and the ISET is 50% and ICAS is 50%. Now, what is ICAS made up of? The tasks, we have test two, and then we have the weighting of, in terms of ICAS, it is 10% times 2, which will give you 20%. The practical assessments 2, and the weighting is 25 by 2, which is 50%. Your internal examination is 1, which is 30%. Now, in terms of the national assessment and weightings, we look at level 3 on your left-hand side. The paper 1 is 120 marks and for 3 hours, which is a theory paper. Your paper 2 is 100 marks, but it is 3.5 of a paper. So how is this paper broken up? If we look at the paper 2 first, the practical as shown on the right-hand side, topic 1 is 2%, topic 2, 18, topic 3, 20%, topic 4, 10%, and topics 5 to 12 is 50%. This is forming part of the practical paper. Then when we go back to the theory paper, which is paper 1, topic 1 is 20%, topic 2, 20%, topic 3, 10%, topic 4, 10%, and topics 5 to 12 is 40%. Now, the sample national exam paper 1 and paper 2, we are given a breakdown. So if we look at the first paper, which is paper 1, we've got 8 questions. In the first one, we have a mixed question, question 1, mixed question, topic 1 to 12. They've given you a suggested time, which is 7 minutes, and mark allocation of 5. Question 2, mixed questions as well from topics 1 to 12, and we are suggested time 8 minutes, 6 marks. Question 3, mixed LOs, topic 1 to 12, again 10 minutes and 8 marks. Question 4, topic 1 is 28 minutes and 20 marks. Question 5, we look at topic 2, which is 28 minutes and 20 marks again. Question 6, topic 3, 16 minutes, 11 marks. Question 7, topic 4, suggested time 13 minutes, mark allocation 9. Question 8, we look at topics 5 to 12, suggested time 60 marks, and a cumulative mark of 41, giving you 120 marks, and a suggested time of 3 hours, 180 minutes. Paper 2, which is the practical paper, question 1, topics 1 and 4, suggested time 32 marks, which is 16 marks. Question 2, topics 2 and 3, which suggested time 48 minutes and 24 marks. Question 3, Topic 3, 24 minutes, 12 marks. Question 4, topics 5 to 12, suggested time 36 minutes with mark allocation 10. And question 5, topics 5 to 12 again, suggested time 60 minutes with 38 marks. And checking of answers is also allocated a time of 10 minutes. And in total, it is 100. Now, we don't have a sample national paper, but we have a breakdown of the national paper. But I am happy to say that this book provides support in terms of a sample paper 1 and a sample paper 2. And that brings me to the end of my presentation. Thank you very much. Goodbye and good luck.